So you do not use your free hand for ray diagram. Use straight edge. Okay. So we are told that two plane mirrors, M1 and M2, M1 and M2 are inclined at an angle theta as shown. A ray of light 1, which is parallel to M1, strikes M2, and after two reflections, the ray 2 becomes parallel to M1. Find the angle theta. So we have the two mirrors inclined to each other by an angle theta. So if this is mirror 1, then this, of course, will be mirror 2. The angle between the mirrors, we are told, is theta. So if the angle, now a ray of light 1, which is parallel to M1, strikes M2. A ray of light 1, which is parallel to M1, strikes M2. So this ray, please, when you come in, mute yourself for me. And rays must be indicated by arrows. So this ray is parallel to M1. It's incident on M2, and after two reflections, so reflection 1, after striking, this is a ray. So reflection 1, and then the second reflected ray, or during the second reflected ray, the ray becomes parallel to M2. So this also becomes ray 2. That is the diagram. That is the diagram. Okay. That is the diagram. So ray 1 is parallel to mirror 1 and strikes M2. After it undergoing two reflections, when it strikes, one reflection, two reflection, the ray 2 becomes parallel to mirror 2. This is the diagram. And so the next question demands that we find the angle theta between. The hint I gave you last time was that if two lines are said to be parallel, then they are slope, or they must have the same slope or gradient. So if this line, if this is the vertical, this is line 1, this is another line, and I claim this line is parallel to this, then the angle between the ground to the lines must be the same. If they are also inclined at an angle to the ground and the two lines are parallel, then these angles must be the same. If they don't have the same angles or slope, then they are not parallel. Okay. So when two lines are parallel, it means they have the same slope or gradient. Elizabeth, mute yourself for me. Okay, so that is what we are going to apply. We are told ray 1 is parallel to mirror 1, meaning this angle between the mirror 2, which is on the ground, and then mirror 1. this angle theta must be equal to this angle from the mirror to ray 1. So if this is theta, this is also theta. Ray 2 is also parallel to mirror 2, meaning that this angle between the mirrors must be the same as this angle, or when I extend the mirror, this angle must be equal to this angle. They all correspond. Okay. Now, this is an incident ray. This is reflected ray from mirror 1. Whenever there is an incident and reflected, there must be a normal. So if we draw a normal at this point, this becomes angle of incidence, I, which is equal to I. By this, it means that this angle would also be equal to this angle. So theta. In the same principle, this is incident ray, this is also reflected ray. So when I draw a normal, I have angle of incidence I, which is equal to angle of reflection. So by that principle, theta here will also be equal to theta here. So I have this triangle A, B, C with interior angles being equal to theta, and then that. Please, a second, I'm coming in. Let me take this call from school. So if the interior angles theta, then we can sum these interior angles theta plus theta to be equal to 180 degrees. So we have 3 theta being equal to 180. Therefore, theta equals 60 degrees. So simply you need to use the idea given. You are told ray 1 is parallel to ray 2, mirror 1. Ray 2 is parallel to mirror 2. Use that idea that if this is parallel to this, then the angle, okay, the slope will be the same. On and on and on. And that's it. That's it. Now, we can also use this triangle. Look at something. Okay, once we can also find the angle of incidence here. The angle of incidence is equal to the angle of reflection. We can calculate for the angle of incidence once we know theta, and we can use this. Once this is 60, this is 60. So you have 2. It means that this angle alone, okay, is 2I plus 2 theta must give us 180. Okay, so if theta is 60, then 2I is equal to 180 minus 120, 2 times 60. And this is also 60. Therefore, I here will be equal to 30 degrees. And that's the same value we'll have here and then here as well. Okay, so it isn't so difficult. Use that idea. I would send you similar question. Okay, Elizabeth.
Please, can you come again?
With which parts?
Like how you got the 60, the
Okay,
like
so
yeah.
pay attention. So the idea is that we are told that ray 1, this ray is parallel to. Please, when you come in, mute yourself. Ray 1 is parallel to mirror 1. When two lines are parallel, they have the same slope. So if this line is parallel to this line, then when I draw a horizontal, the angle between the ground and this line, if it's theta, must be the same as this angle. Why? Because the lines 1 and 2 are parallel. So if ray 1 is parallel to mirror 1, then the angle between the two mirrors, which is theta, must be the same as the angle between the mirror 2 and ray 1. So this is theta, this is also theta. Okay. Then we are also told that after the two successive reflections, ray 2 becomes parallel to mirror 2, meaning that this angle must also be equal to this angle, because when two lines are parallel, they have the same slope. Or this angle here must also be equal to this angle here, because they correspond. Okay. Because they correspond. Corresponding angles are equal, and the two lines are parallel. Lizzie, are you okay? Lizzie, are you okay?
Yes, please.
Okay. So if this is theta, this is theta, this is also theta. When you analyze angle of incident, angle of incident ray, reflected ray. So when you draw normal N1 and then another normal N2, this is I, this is also I. This is I, this is also I. Now, if this is equal to this, then we can conclude that this angle also corresponds with this. If this I is equal to this I, then we can make the conclusion that this angle here is also equal to that. In case you want to be sure whether they will be equal, look at it. Assuming I don't know this, and I'm representing it with A. The angle between the normal and then the mirror is 90. So it means this angle I'm representing as A plus the angle of reflection I must be equal to 90. Therefore, the A, the unknown, will be equal to 90 minus I. Okay, so this is 90 minus I. Then we can get the same thing at the other end. So this is 90 minus I. This will also be 90 minus I. Okay. This part is 90 minus, this part is 90 minus I, meaning they are equal. The angle here is equal to angle here. So if this is theta, then this will also be theta. So that we have the angles within the triangle to be theta, theta. When you sum them up, 3 theta is equal to 180. Theta, therefore, is equal to 60 degrees. Now, I saw some of you calculating for the angle of deviation to mirror 1 and mirror 2. Okay, so the idea is that this is ray 1. It's supposed to go straight. This is its original path. By virtue of its interaction with the mirror 2, its path is deviated to this. So this whole angle becomes the angle of deviation. Okay. Now, how do we determine this? This is now 60. Meaning this is 30. This is also 30. Okay. The whole angle is 180. So if this is 30, and this is 60, okay, this will certainly be equal to 60 plus 60, 120, 60. So the angle of deviation becomes to the first
We have
mirror.
what it takes to also do what we want to do.
Cedric, please mute
All right,
yourself.
the guys under
Cedric,
21
mute
set up
yourself.
the Black Princesses. Now, it's some men's football and the Black Stars forward.
So to mirror 2, the angle of deviation is equal to 120 degrees. And we'll have the same thing happening in mirror 1 as well. Okay. Mirror 1, when we extend this line, this is supposed to be the original part, but its part is deviated. So they have the same angle, and so that's what will happen. All right. I'll send you a similar question to analyze. When you are given problems, please spend time to analyze. It really helps. Okay. Please, any question? All right. Let's quickly move to formation of images in plane mirror. Today we must finish mirrors. Then in our next meeting, we'll look at spherical mirrors. Formation of images in plane mirrors. So, formation of images in plane mirrors. So the question is that if you are asked to use ray diagram to form an image formed in a plane mirror, how are you going to do that? So let's quickly look at the rules governing this and then apply. So this is my plane mirror. Once it's plane, it means one end must be coated. An object is here in front of the mirror. I'm to use ray diagram to form, of course, plane mirrors gives us virtual image, but we will understand why the image form is virtual. Now we see as a result of reflection. So if I can see somebody, then it means light from an external source incident on the person, reflect from the person's body, and then received by my eyes. So we see as a result of reflection, implying that whatever we see, there are a lot of rays, reflected rays coming from the object. The reason for which when there's no light, we can't see. Meaning when there's no light, it means no light is incidenting on the objects or on the body and then reflecting into our eyes. So an object in front of a mirror has a lot of rays coming from it. Has a lot of reflected rays coming from it. In drawing ray diagram, we use maximum of 3 rays. It can be 2, it can be 3, but maximum 3 rays or even 2 to draw an image. We don't litter around using rays. Just even though a lot of rays come from an object, but we are almost always using about 2 rays to form the image. So this is the object O placed in front of the mirror. how do I trace this image? Okay, the first rule is that a ray of light coming from an object which is traveling perpendicular to the mirror. So if a ray is coming from the object, hits the mirror perpendicularly, meaning makes an angle of 90. The mirror, the reflected ray passes along the same path. So when the first rule is that when the ray is perpendicularly to the mirror, it is reflected along the same path. That's the first rule. That's the first rule. So once the ray hits the mirror at an angle of 90, it will take the reflected ray, take the same path as the incident ray. So this arrow indicates incident, and the second arrow shows reflected along the same path. 2, a ray of light incidenting on the mirror at an angle. So when the ray hits the mirror at any different angle, apart from 90, example this. Incident. The ray reflects and obeys the laws of reflection, meaning there must be a normal drawn. The normal is also perpendicular to the mirror. So draw a normal from that point. Once the normal is drawn, it means this is the angle of incidence must be equal to angle of reflection. Okay. Now, before you draw the angle of reflection, one of the characteristics of images formed in a plane mirror is that object distance must be equal to image distance. Object distance must be equal to image distance. So you must follow this rule, meaning that we must measure this distance from the object to the mirror and then get the same thing. So if this is X, centimeter, we need to have X centimeter also measured at the same point. So we extend this horizontal line. We extend the horizontal line at the back of the mirror so that object distance will be equal to the image distance. And that is where our reflected ray will be taken from. So we trace the reflected ray to this point. This is the reflected, and then we trace it to this point. So this is the reflected. Now, even this alone gives us the image position, but I can include a third ray. And the third ray is that, okay, another ray hit from the object hitting the mirror. at any angle either than 90. So incident, it will reflect to obey the laws of reflection. Angle of incident equals angle of reflection. So if I draw a normal, a second normal, then the reflected ray must also link this point because object distance must be equal to image distance. So I trace the reflected ray to this, also to that point. So maximum 3, but it can be 2. So this is the object, this is the image. I'm using broken lines because the image formed is behind the mirror. Once it's behind the mirror, then it means that virtual image will be formed. It means that, so this is the image of a point object. Point object. The object looks like a dot or point. The image of a point object. This is how it will be formed. This is how it will be formed. Okay. Now, an image will be formed whenever 2 or more reflected rays actually meet. An image is formed whenever 2 or more reflected rays actually meet or appear to be meeting. Now, when 2 or more reflected rays actually meet, real image will be formed. When 2 or more reflected rays appear to be meeting, virtual image will be formed. Look at this. I have 1, 2, 3 reflected rays. Looking at how diverted or spread out they look, there is no way they can ever meet in front of the mirror because they are being diverged the more. So it implies that because they cannot meet in front of the mirror, no real image will be formed in front. Then it means, let me trace the reflected rays backwardly. So when you trace them backwardly and they appear to meet at a point, that point is where the virtual image will be formed. The reason for which this image is virtual, it is because the 3 reflected rays do not meet in front, but they appear to meet at the back of the mirror. The reason for which we are having a virtual image of this point object. Please, any question? So for point objects, we are going to look at for an extended object. An extended object here, we are going to look at an object with a head and then a foot. This has no foot. It's just a dot. The reason for which we are terming this as image of point objects. Please, when you are drawing this, ray diagrams are drawn with straight edges. Mamiya.
This the first rule. When the ray is perpendicular to the mirror, it is reflected along the same path. What does it mean for it to be reflected along the same path?
Look at the path. Mamiya, look at the path of the incident ray. Look at the path of the reflected ray. Along the same path line. In the second rule, look at the incident ray. Leslie, mute yourself. In the second rule, look at the incident ray and then look at the reflected ray. They are both in different paths. This is going here, this is going here. But for this one, they are all along the same path. It's like if it has been two people, they will definitely clash. Okay. But in this case, there's no way they will clash. Mami, are you okay?
Yes, please.
All right. What's your assignment never came? So let's do it for an extended object. We are going to go through the same rules. So for extended objects, meaning an object with a head and then a foot. For an extended object, we usually we put the object on a horizontal line. So the foot of the object is on the line. So there's the head, and then the foot is also on the line. So here we are not going to draw a human being with head and no, just an arrow to indicate the head. Okay, just an arrow to indicate the head and then dots to indicate the foot. The same rule. Let's draw the image of the foot first. So we can use this horizontal line to be a ray perpendicularly to the mirror, which will reflect along the same path. Right. Then we would require another ray to indicate position of the foot, at least 2 or 3. Let's go by 3 rays to indicate position of the foot, to indicate position of the head. So another ray, but this time the ray is at an angle. Hello, I'm coming in. Just give me a minute. So another, where's my, okay, I'm coming. Yes, whoever sent the good morning, please, I saw it. Another ray from the foot. Incident at an angle must reflect to obey the law. But before you do that, because object distance equals the image distance, you must measure this distance. Okay, so when you measure, I am estimating, you must measure. Because that is where you need to trace the reflected ray. That is where you need to trace the reflected ray. It can't be at any other angle. If you don't do that, in fact, you are wrong. So incident reflected. So it means that, you see, this reflected ray, this one, they will never meet. So we are projecting the reflected rays backward where they appear to meet. So we have the position of the foot of the image. We are left with the head. Another rule, a ray hitting the mirror perpendicularly from the head would reflect along the same path. So incident reflected. A ray from the head hitting at an angle. Let me increase the aperture of the mirror. So at an angle. Will reflect and obey the law. But then you trace the reflected ray to that point. So let's extend the horizontal line backward. And object height must be equal to image height. So a perpendicular line from this point would give us the image height, so that we can trace the reflected ray to this point. This is the reflected ray. And so this position becomes the head. By this, object distance equals image distance. Object height equals image height. So this does it for an extended object. Just two rays to form the head, and two rays to form the foot, and you are good to go. So this is using ray diagram to form the image of an extended object placed in front of a mirror. Okay. Okay. Bridget, please yourself for me. Now, I think Bridget is not hearing me. Let me mute all. All right. The other information is that the images formed in a plane mirror are laterally inverted. So let's also use a ray diagram to have lateral inversion. Maybe the image of the letter F, P, A, or any other letter. I'm going to try one so that. So please, when you finish, you indicate this is the object and then there's the image. So beautifully. Maximum 2 rays to form the foot, 2 rays to form the head. You don't litter around with rays. Just 2, 2, and you are good to go. Do I clean it? Do I clean it? Yes. Because I'll be writing here and it will block whatever I've done here. The reason for which I'm asking. Anyway, I'm also recording, so if you miss that out, you can still get the video, right? So we are going to draw to show lateral inversion of images in a plane mirror. Lateral inversion. Still our mirror. Let's draw a horizontal line. This time we have the letter F. In front of the mirror. A stylish F. Hey, Caleb, then what's the situation? Is it blurry or what? If so, I think it's a network problem. Either you join, okay, you go off and rejoin to fix the problem. So we are going to show lateral inversion. First, because object distance is always equal to image distance, measure this. I can measure this, meaning the image will somewhere be here. Then this line can be a ray from the foot. Then I draw another line to form the foot, just the foot. I want to go through this quickly. So I formed this one. Now image height equals object height. But before then, I must draw the head. So a horizontal line, which is perpendicular dot. This is a ray. So from this point to this, I have the back of it. And at this position, you can just measure. You can take measurement. This distance must be equal to this distance. Okay. Then another horizontal ray. And this distance must be equal to this distance. Now look at it. We have the letter F, which is laterally inverted. Or let me even clear the rays for you to see. Because in real world situation, you will not see the lines, the rays, but they are guide. I'm not saying when you finish, clear the rays, no. But you see the letter F, which is turned laterally in front of the mirror. Okay, so you can try that later, try that for P, A, J, and B, and all the letters. Please, any question? Any question?
No, sir.
All right. Let's move on to, I said we
No.
are finished. Please, if you are asking, if you want to ask something, please go ahead. Before we continue, let me quickly take shots of attendance.